Hi everyone, this is Aruna, Richame Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about the technology and performance in the computer architecture. So before entering into the performance, while seeing the technology trends, it will be growing upward when compared to the memory capacity. Nowadays, we are using double data rate RAM, that is a random access memory. Here capacity is year by year it is increasing, and also your power consumption is going down. And also we are now in the fifth generation, that is ultra large scale ICs. So these are the various technologies are used in and their performance. So initial days we are having only a lower performance. Nowadays our performance has been increased. So how the electronic technologies are evolving means only based on the capacity and performance. If my capacity and performance is increasing, definitely it will reduce the cost of my product. So this both the cases can be occurred only through these two parameters. One is a response time, another one is a throughput. Response time is nothing but the how long a particular task, how much time it will take to execute a single instruction or a single task. That can be called it as a response time. Throughput rate is at particular time how much amount of work can be completed. That can be called it as a throughput rate. This both is thing is very much important while while considering the performance. If my performance is increasing, my technology is also increasing. This both the thing is affected only how we can affect these two things is while replacing the processor with the faster version, or I have to add the more number of processor in my architecture. Then only this both the thing can be work it out. So all the cases, if my response time is decreasing, definitely my throughput rate is increasing, my performance also increasing. So only we are considering these two things is a very, very important part. So the next thing is a relative performance. Your relative performance is inversely proportional to the execution time. So if it is like this, we can say X is n times faster than Y. So your N relative performance N is nothing but execution time divided by execution time. Similarly, I quoted one example. In this case, computer A runs the program in 10 seconds, computer B runs the same program in 15 seconds. How much faster means we can calculate the ratio as 15 divided by 1.5. So directly we can say A is 1.5 times faster than B. The next thing is execution of a measuring execution time. So for measuring an execution time, we are considering two types of a thing. One is the elapsed period, that is a delay period, or we can call it as a total response time. So total response time only determines the system performance. Example, processing, IO, OS, overhead, ideal time, everything we can come under the elapsed time. Second thing is CPU time. CPU time is total amount of time spent by the processing of a given job. So it is a comprise of two types of a time. One is a CPU time, another one is a system CPU time. Another one is a user CPU time. User CPU time is for giving input to the user. That particular time we can consider a user time. Processing time we can call it as a system CPU time. Different programs are affected differently by CPU and the system performance. Now here you're having a clock. Clock can be constant rate at particular clock. So we can call this is a clock period. That is the duration of the clock cycle. And also clock frequency equal to cycles per second. So my starting of the gauge and the ending of the thing only, your status can be updated. Remaining thing is the data transferring stages. So CPU performance formula is the execution time formula is CPU clock cycle into clock cycle time. Clock cycle time, we can call it as a 1 divided by rate. So we can rewrite our equation as CPU clock cycle divided by clock rate. Here, here your performance can be improved by three ways. One is reducing the number of clock cycle. The another one is increasing the clock rate. If I want to change the hardware design, must often trade off the clock rate against the clock on, so my performance can be improved. This is the how a performance can be improved. For example, simple program I have quoted over here for improving the performance. Second thing is, so how the instruction performance can be calculated is that in the clock cycle, we can call it as a instruction count into CPA. That is a cycles per instruction. For that, I have quoted one example over here. So generally, your CPU performance equation can be rewritten as we already calculated CPU clock cycle equal to instruction count into cycles per instruction. So we can rewrite our CPU equation as instruction count into CPI into clock time. Clock time, we can write it as a 1 divided by clock rate. So our CPU execution time equal to instruction to count into cycles per instruction divided by clock rate. So this is the how a CPU performance equation can be calculated. For that, I have quoted one how we can compare the code segment. So along with the CPA, how it can be done, that I have given one example. So performance summary, how we can calculate the unit means. For the instruction count, we can able to represent it as instruction per program. For CPA's clock cycles per instruction, clock time is seconds per clock cycle. Everything will be cancelled. So final unit is a seconds per program. So for CPU execution time unit is the seconds per program. Here your performance depends on the 4 factor. Either it can be algorithm or programming language or compiler or what type of an architecture we are using. So your performance trends also while moving the upward direction, each and every time my clock rate is increasing means your power also reducing. So this is the how it can be worked. For CMOS IC technology, your power can be calculated as a capacitive load into voltage square into frequency. This is the how a power can be calculated inside the processor. That's all about the technology and performance. Kindly watch my video. Upcomingly, I'm going to detailedly explain about the memory operation, instruction, everything. Thank you for watching my video.